Hello.
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 So it's 1 o'clock and we have a lot of material to cover. So I'm not gonna wait too long to get started. The first part is kind of just introductory anyway. But I wanna make sure that we get through all of our examples and stuff today. So 1 second, let me pull up my screen. Okay. Hopefully you guys can see just the first slide, right?
Yes.
I don't like the presenter view. I'm just gonna take attendance really quick. Okay. So for today, we have a lot to cover. I know there was a lot of material in the first week. There was 3 chapters, but pretty high level going through the Excel spreadsheets. And hopefully if you did the reading and kind of looked at the examples, you'd see it looks like a lot of material, but each example was kind of just covering primarily like 1 or 2 higher level Excel concepts. So they should it should have been manageable, and then we're going to go through most of those examples today as well, so you can actually see me in the spreadsheet and how I click around and find things, and we'll talk about the formulas and stuff. And then in the next upcoming weeks, it's one chapter at a time. The content will be a little more advanced in the upcoming weeks, but there will be fewer examples to go through in Excel. So we're gonna start out. I'll introduce myself a little bit. I did post an introductory video as well, and then I'd love to hear a little bit of a hello from you guys, and then we'll jump right into the first part of our lecture, take a break, and then do chapter 2, another break, and then we'll finish up and do our discussion, which was about the different types of analytics. So again, my name is Kelly Scarborough. You'll see the W. I actually transitioned back to my maiden name, which is Wutzke, but not with the university yet, because it's like a whole ordeal. So in the future, you might see me as either or, but for now, just Kelly Scarborough. I work for a small management consulting company that's DC based. I am a subject matter expert in cost estimating, so I build large cost models, meaning like $1.5+ billion for FAA IT programs, so for the Federal Aviation Administration. And that usually entails putting together lots of detailed estimates on estimating software, hardware, and other national airspace components, compiling them all together, adding inflation risk, all sorts of other things, and then providing a life cycle cost estimate. And as part of that work, I do a lot of analytics. We have to quantify benefits, and I'll often do things like regression analysis for obtaining or estimating the cost of certain items. So you could imagine, like, if I were doing a cost estimate for the Navy and they wanted to build a ship and they had some component of the ship's engine, and we know from data that the weight of the engine tends to drive the cost, I would, compile all that data, apply a regression to it, and figure out if, given the new weight of that component, I could figure out what the cost should be, and then I'd plug that into part of my cost estimate. So that's what I do. I actually manage analysts now, so I don't do a lot of actual hands-on model building myself, but yeah, I have a really cool job. So if you guys ever want to ask me about it or have a side conversation, or you want to know more about the industry, cost estimating in general, I've been doing it for 14 years, since I was 19, and I started in ops research with the Corps of Engineers in college. So just happy to talk about that at any time. So, okay, so I actually can't see the time while I'm, all right, just to say hi really quick, and then maybe just like, I know you guys did your student introductory assignments, but just like a couple sentences about yourself when I call on you, just so I can make sure you're actually here, and then we'll get right into the lecture. So it's Elena, is that correct? Maybe not. Jackie, are you here?
Yes, that's me. Hi.
Oh, sorry.
No worries. I thought we were doing intros.
Yep, just wanted to say hi and maybe what you're, most focused on for this class.
Oh yeah. Well, I'm an international student, and this is my second last quarter. I will graduate in September, so I hope that this class will be very helpful for me during the last class, which I will take in summer.
Awesome. Okay. Congratulations on the soon-to-be graduation. Jackie, are you here?
Yes. Yeah, hello. This is my first full year at CDU and living in Washington. Moved from Maryland. I miss the DC area very much. I'm kind of bummed out. I don't get to be at the Cherry Blossom Festival this year. But yeah. So here, excited to learn.
Awesome.
Interested in analytics.
I think I replied to your post. That's where I worked at the Pentagon, and then I worked in that DC area for like 9 years. So yeah, I've been seeing lots of cherry blossom posts from my colleagues, but I missed it this year too. So Tashi, is that how you say it?
Hi.
Did I say your name right?
Yes, Tashi.
Hi, nice to meet you.
Yeah, my name is Tashi. I'm an international student from Nepal, and my major is BSBA, and this is my third quarter
Okay.
at CDU.
Awesome. Okay, and then Tyler, are you with us?
Yes, I'm here.
Hey.
Hi. So I'm actually also from Maryland. It's very funny. I'm from around the DC, like Columbia, Fort Meade area. So
Okay.
very familiar with that. So this is my first quarter that I've taken in about 2 years. I took a 2-year break. I was actually in flight school. So I'm finishing up that one right now and kind of figuring out where life's going to take me next. But so I was as I was telling you in the email, I'm a little daunted by kind of the workload here because I'm jumping in like a 400 level class, and it's been about 2 years since I was in there. But as I said, we talked about earlier, I'm going to give it my best and see. I got about a year left on my bachelor's degree. So from there, we'll kind of see where we go, looking to kind of get my master's. So maybe in aeronautics, but it really all depends. Maybe project management, kind of on the fence.
Okay, wonderful. That reminds me, I wanted to show you guys something really quick on the course. So I'm going to keep this announcement pinned, so on Thursdays you can easily find the Zoom link. So new announcements will show up down here. And actually, I really should turn this off of editing mode because this isn't what it looks like for you. Okay. So, like below that, above week 1 and in between the Zoom or where new announcements will show up. In your course content for week 1, I added, you'll find in the slides if you review them later, and the lecture slides that I'm using, I'll post because I don't use all the slides that come from the text, but you do have like the full slides. There's some stuff that covers things that I don't think we need to know necessarily, like it would be too much to cover, which some of those things include like Stat Tools, which is the part of the Palisade software, which is an Excel add-in. So what I did is I added the link for you to go and get that tool. I do recommend that you download it. You just select our textbook, fill out the information. They'll send you an email link, and then you download it's like a zip file, so you have to extract it and then run the software installation. And then it gives you a student version of the software. We're not going to use At Risk, which I actually use for work. We're not going to use it or any of the other things, but the Stat Tools, there's some simple things that you can do that are kind of cool. In chapter 3, I think they talk about like stacking and unstacking some data, and that's actually a pain to do in Excel without this little add-in. So the slides will tell you how to do stuff in Stat Tools. There's like some neater looking charts, some better looking charts. So can't hurt if you want to download it, but all of your like assignments and stuff, I'm going to try to keep you away from that and just stuff that you can do in Excel. But I wanted to point out that I'd put this in here, and for those of you that want to try that out. And if you see a reference to Stat Tools in the slides, that's what they're talking about. So, okay, so back to it. All right. So the objectives, every time I jump in and out, it's going to make me do this, isn't it? I feel like it is.
I'm sorry, may I ask real quick?
Yes.
So the assignments are not from the textbook? They are not
They are from the textbook.
Okay. So, yeah.
Yep. Go ahead. Sorry.
Okay, so we will check in the textbook and do the assignments based on the task, because I saw that there was an assignments tab where all the assignments copied from the textbook.
Yeah, they're all the assignments I selected from the questions in the textbook that I thought was most relevant to the learning.
Okay. Do we have the relevant context over there?
I'm not sure I follow. You mean in the assignments? Do you want me to show you?
Yeah.
Okay, so when you go to assignments, so they'll tell you, so that, oh, do you mean, did I tell you which question number it corresponds to?
Yeah, right.
I didn't. I just pulled a couple of questions. So I can add those references. I don't think it will change anything because this is verbatim from the book, the question, but I can add that in if that would be helpful.
Okay, so that means that we do not need the additional context from the textbook when we look at the assignment tab. Is that correct? But we could use it if we think it's helpful.
Yeah, so like, for example, this question is actually, it's question number 1 from chapter 1. It happens to just also be question number 1, but it's like the same exact wording. There's no additional information in the textbook that would be
I see.
helpful.
Okay, got it. Thank you very much.
Sure. Okay, so, all right. So the premise of this course is to help us understand business data better, to make better business decisions and improve business performance. And a lot of growth in the field of business analytics in the recent years is really just revolves around this idea of big data and this new technology that we have to analyze and derive insight from large volumes of data. So big data is kind of like, it's a pretty popular term, but it kind of encompasses these 4 things: the volume of data, just the sheer amount of data we can collect now. Like if, for example, I did some side work for an e-commerce shop. They sold textiles online, like clothes, only online. They didn't have a factory or a warehouse or anything. They didn't store it. They just procured and delivered straight from warehouse to consumer. And they collected data on like all of their website transactions and purchases through Google Analytics, and you could see down to just the volume of information was crazy, just because of the amount of traffic they have going through their site. So that's already, you know, tens of thousands of visits to their pages every day. But then also you could see how long people looked at a certain site, or where they clicked on the page, how long they stayed on the page, what the quit rate was for that page, where they just X'd out of the whole site and didn't make a purchase, how many, you know, what they added to their cart and took back out, like all these nuanced transactions. So tons of data. The variety, the different types of data we can collect now, it's pretty remarkable too, which also includes like image and video data, which used to be very like expensive and taxing to store, but now it's, you know, basically nothing. Velocity is kind of like how quickly we can transmit data. So think about like the internet and how fast over recent years we've been able to send data through different applications. And then the final like little component of that is veracity, or the uncertainty of data. So we don't, given how much data we're being given, we don't necessarily know how much of it is accurate. But interestingly, the more data you have, the less accuracy becomes important, because you have so much data. All of your insights that you derive kind of wash out some of the bad stuff, if that makes sense. So it's kind of an interesting phenomenon. The book talks about how the implications for this big data, this business analytics field, what it's doing to everybody in the business world. And there's an article that is in your reading, Analytics, The Widening Divide, which is a little bit older, but really highlights the difference that analytics can make in a business. So we can make decisions now where we're not relying necessarily on intuition or having to have lots of expertise in a field. We can use data to help us better determine what our business is doing, what our customers are doing, and to make decisions that may not even be able to, we wouldn't have been able to do manually before. And we can also optimize our processes. Like if we're looking at a production factory, we can collect so much data on each step of production and all those machines and equipment that we can optimize that process, manufacture most efficiently, and then in turn, we maximize our revenue. So you'll hear like business analytics and data analytics used interchangeably in the book, basically the same thing, but you know, we are talking about in general large data sets. In your Excel examples and stuff, we're not going to be using large data sets. They'll pare it down so it's manageable for you, but when you apply these concepts to real life, generally you're looking at really huge chunks of data. And more advanced classes that build off of this class might go into like mining data, cleaning it, stuff like that. But we're really more focused on the quantitative methods for analyzing and making decisions once we already have data. So there's some statistics in this book, and then management science. We are not going to get heavy into math, but there are some statistical concepts that you need to understand, and the book will cover those. But as we go through lecture and stuff, I'm not going to like pick apart formulas or derive formulas or make you memorize formulas, because all of those formulas are functions in Excel. So you don't actually even need to know how to calculate them. You just need to understand what they mean. So again, in this book, analysis, decision-making, and then how do we judge the precision of our estimate? How accurate is it? How much uncertainty exists around it? Because if we're stating an observation about a data set, we need to know how much confidence we have in that estimate. And then in that article, they talk about some core competencies in the field of business analytics. It's a really good article. I think this is pretty accurate from what I've seen and kind of being in this field for a long time. So really, as a data analyst, managing data, understanding it, and acting on it are your like big buckets. And the courses that we offer at CityU cover different aspects of this. Like, for example, there's a data visualization course that really goes into the skills and tools section in a very targeted way. But basically, we need somewhere to put the information and manage it in a standardized way, and then be able to access it. Then we need the tools and the skills to use that data, derive insights from it. And then we need a culture in our workplace that accepts data as part of its decision-making process, so that our leadership will use the insights that we derive to build better strategy and better operate their companies. Okay, so you already know we're using Excel in this book. I provided this really nice file, this Excel tutorial file. It's in the content for module 1. If you're brand new to Excel, actually, even if you're not brand new to Excel, it's a really great file. I recommend you save it and just keep it forever. It has like tutorials on every imaginable feature in Excel. But if you get stuck on one particular feature, you can kind of consider it like a help or a reference book, and you can go look up that particular feature and learn more about it through this file. So highly recommend. Excel, we later on will also be using some of the add-ins, and we'll cover how to add those in if you don't know how to enable like the solver add-in or the analysis tool pack. I can post a video or some help. We'll make sure that you have those enabled. They're already built in, you just have to turn them on. I don't know why they're not just on already, but they're not. Then we talked about Stack Tools, so I provided the link for that as well. I'd really love it if everybody was able to enable it, just so that you could play with it. It does have some really cool features. So, okay, so let's get into the spreadsheet modeling, because I want to start looking at examples in Excel, since I think that's where the core utility in doing lectures is going to be. So spreadsheet modeling is really important. In past versions of this class, when we've taught it, there wasn't a big emphasis on how you properly set up and model a spreadsheet. And so I would frequently get assignments that were very difficult to read, that had calculations, and I didn't know whether or not it was, what it was calculating or why. Things weren't noted nicely. This textbook really helps set you up so that you can build spreadsheets, like when you apply this to a job, that you would actually turn in to another person. You would turn them into your boss or another analyst, and they would be able to follow your work, which is really important. You don't want to be turning something into somebody where they don't know what's an input, what's an output, what's being calculated, where the point of your spreadsheet is, right? So the examples that we're going to go through here in a minute will show you the book's best practices for laying out spreadsheets, and they're the same practices we're going to follow throughout. So anytime you modify or create a spreadsheet for an assignment, it should look a lot like the assignments in the textbook. And for the most part, you're actually building off of an existing, so they've already done the work for you. But I think later down the road, there might be 1 or 2 assignments where you create like a simple, thing on your own, and you'll want to follow the same aesthetic principles. So inputs are fixed values. Decision variables are things where we control them. And then outputs are like calculations or what changes given different inputs or decision variables. And we'll apply that language in our examples. So we want to enter input and decision variables, relate them by means of different formulas, and obtain an output. Really that simple. So for the first example, we're just going to look at a basic spreadsheet. So they walk us through this pretty nicely. This is just some information. This would be like the bare minimum type of spreadsheet for this example. They're looking at t-shirt sales. They have demand, which is just a number, order, which is also hard coded, and then they have this profit formula, which appears to be some hard coded numbers, 750, negative 750 minus 8. We don't know what those things are, the significance of those numbers, times the order amount, plus some if formula that says if the demand is greater than the order, 18 times the order, otherwise 18 times, see how hard it is for me to go through this? It's not great. I don't know what 750 came from. I don't know where 18.6 came from. I don't know what those things are. This is not helpful at all. We don't want a spreadsheet like this. So a slight improvement would be to take those hard-coded numbers and pull them out separately. This is slightly more helpful. In this case, we have that 750 was our fixed order cost. So that's telling us like for every order, there's a $750 cost, no matter what, like a processing fee or something for the factory. There's a variable cost, which happens to be $8, a selling price, which is $18, and then a discount price, which is $6. And I think in the example, it tells you the selling price is, let's see, let me pull it up really quick. Okay, so yeah, the price, the $18 price is only charged until a week after this NCAA tournament, and then he sells the remaining shirts at a discount of $6 because he has this leftover inventory he wants to push out. Okay, so all of those variables are now put out here. So we don't have any formulas anymore where there's any fixed numbers. So there's a slight improvement on the past formula here, but still a lot to look at. So we're gonna continue to improve upon this. And I will stop here to talk about this if formula. It's gonna look a lot better going down the road, but the if statement is really nice in Excel. And the way it works is it takes 3 arguments. It takes a logical test, so you put in a condition. So if some cell value is less than 10 or greater than or equal to or whatever your condition is. And then the second argument it takes is what that value is if it's true. And then the third argument is if that's not true, if it fails the test, what is the third, what is that value? So we'll see a little more clearly how they're using the if function as we improve upon this spreadsheet. Okay, so here, there's not much change other than they named some ranges. And the way you name a range, there's 2 ways to do this. Let's see. So see right here how it says this is cell I3. You can actually just change the name here, which I'm gonna escape out of, and that will name this cell right here for reference later. So you can see this one is called fixed order cost, which makes sense, right? Because it's right there. Variable cost, selling price. So they named these, and you'll see why that's useful in a second when you look at the formulas. And then it's really nice to make a list of the range names that you do use and what their reference cells are. And a quick way to do this, so 2 things. Hold on, I gotta get rid of this little thing over here. Did not want it to do that. Okay, so you can come here to formulas. This is your naming section. If you know you want, like in here, see then they name their cells according to their names right here. So you can just do create from selection and tell it, I want to use the value in the left column in this case, and then it will name that value. So that's a quick way to do it. Then if you want to see all the range names you have, instead of doing this by hand, typing these out by hand, once you're done, come up here, go to use in formula, paste names, and then click this paste list, and it gives you that whole list. So you can just wait till the end and then throw that in there. But I recommend whenever you send something to somebody else that you do paste that list at the end. If you change anything, like if you move these things around or change names, you'll have to repaste that. You'll have to go do that little exercise again. And just so you guys know, I am recording this, so if you want that file later, you want to go back and like look at how I click through things, it will be available to you. Okay, so now when we look at our profit formula, this is a lot easier to read. It's still a big formula, but now I know, okay, my formula is negative fixed order cost minus the variable cost times the order plus, and then here's our if statement. So if the demand is greater than the order, then the value, so that's the condition. If the demand is greater than the order, in which case that is, then the value, if true, is the selling price times the order. So that means we sold all the t-shirts, none of them at a discount because we had more demand than we could produce. So we sold them all for 18. That would be like the ideal scenario. If that's not true, then however many we sold times the selling price still is true. And then the remaining, the order minus the demand times that discount price. So we're assuming he does sell them all, but some of them are being sold at a discount. So that's the kind of the value in naming ranges. When you do formulas, you can see them, but we can still make this spreadsheet better. So in this case, we know from that profit formula that we have kind of two components. We have our costs, which we're subtracting from our revenue, and that gives us our profit. So we can show our fixed costs. So this is just the fixed order cost. The variable cost is this $8 times the amount ordered. So there's a fixed cost for the order and then a cost per t-shirt. And then revenue is the full price. So this was that demand. If the demand is greater than the order, it's the selling price times the order. And then if not, it's just the selling price times the demand. And then the custom amount. If the demand is greater than the order, there's nothing. There's no shirts being sold at a discount. Otherwise, the value if false, we take the discount price and we multiply it by the order minus the demand. So they basically just broke up that big long formula into kind of those two components. So now our profit just becomes these things, the revenues minus the cost. Okay. Finally, they do some color coding just to help you know what's going on. It's great as an analyst to be consistent with stuff like this. So they use blue for inputs, red for decisions, and gray for outputs. So the whole point of this spreadsheet is to calculate profit. So that's why it's gray. The order is what changes. So if we make our order higher, so now we've ordered 1,700 shirts, but we only have a demand for 1,500. You can see now some of those shirts are being sold at a discount. Okay. So the key takeaways from this were just how we're going to set up our spreadsheets and then that if statement. So one more time. Condition, true value, false value. If statements are very handy. We'll use them a lot, so you'll get to see different ways of using that formula in the future. And there's lots of documentation about these formulas too through Microsoft. If you ever feel like you're not quite have a good grasp on a formula, you can always look it up and do some more reading on that particular formula. All right. So in the next example, we have a company that wants to project its cost of producing products, and it knows material and labor. So we're just going to build a really simple table and a little chart to visualize it. So the whole point of the next exercise is to continue learning good practices for spreadsheets, copyable formulas, with relative and absolute addresses, which sounds complicated, but is a pretty simple concept, and then creating line charts. Okay, so again, they've set this up with inputs, which are in blue. And in this example, they're building these bookshelves, and they have cherry and oak, and there's some material requirement and labor requirement for using cherry and oak. It looks like it's the same amount of materials and labor, so that is kind of agnostic of the wood material. However, cost is different. So cherry costs more per board foot and is projected to increase the cost every year by a little bit at a faster rate than oak. Labor is currently $18.50 an hour, and they expect that to increase annually 1.5%. So before we talk about what they did here, so they wanted to build a table, and they wanted to calculate out the cost per board foot of cherry and oak over time, and then per the hours, how that changes over time. And then they use that to calculate the cost per bookshelf. So they're basically taking the cost of the cherry times the labor to get the total cost plus the amount of material used. So when you're setting up a table, you might want to think about how you set up your table so that it's nice and clean and that your formulas will copy. So the reason they set it up this way, they have their years, so current year and then through 6 years out. When they do it this way, you get your values going down. So we're going to have a formula here we can pull down, and then we get our values, our calculations going across. So they took their initial inputs, which they just tied to the corresponding cell. So you can see that's year 0. And then the basic calculation for the cost is going to be the amount of boards of board feet of cherry times the cost per board foot, plus the labor hours required times the cost of labor. So that makes sense. And then oak is just with the oak values. Now this formula, the way the book is going to recommend this, let me just clear this really quick. The fastest way to clear a formula is to just pull it down like this. So you can see, like, when I highlight these two, this little cross appears, and then I can just pull the formula down. The reason this works, it would not work unless we talked really quickly about relative and absolute references. The reason this works is because we have some fixed values. So when you refer to a cell, for example, let's just do it this way. I'm referring to B5. Right now, this is row and column relative, meaning if I take this formula and I pull it down, it will change according to the row and the column. So if I pull it down, it's going to change down to B6. If I pull it over, it's going to change to C6. So that's what that means by relative. But in this formula, I don't want my price to change as I pull this formula down. So I'm going to, it's this formula right here. If I say equals B5, that $sign in front of the row makes the row absolute. So it will always stay on row 5, but if I pull it down, it's going to stay. Oh, I didn't save, sorry. I didn't save my reference. Okay, so now it's there. It's going to stay at row 5. However, if I pull it over, it will change to column C, but always row 5. So that's what that does. So that allows us to fix the price in this column on board's feet required. And the reason we didn't fix it on Cherry is because we can actually pull this formula over to Oak. So we only have to write the formula one time and then it will move over to Oak. So this right here is fixed on labor hours, that row. See how it's absolute to row 6? And then you can also make it absolute on a column. So in this case, D19. So we want, when we multiply this formula down, we want it to stay on column D. We want it to stay on labor, but we want it to adjust to the increased labor price each year. So we want the row, so we want this formula to become D20 in this cell, D21 in this cell, corresponding to that labor. But we don't, when we pull this formula from Cherry over to Oak, like this, we don't want the labor to move over from this column to this column, that reference. Otherwise, we'll be multiplying by the cost per bookshelf of Cherry and not labor. And then finally, you can also fix on both and make it like a fixed absolute reference, both cell and column, no matter what you do to that formula, where you drag it down, up, sideways, across, it's gonna stay at that reference right there. So that's what those references mean. That's super handy because again, we can take this formula, we can plug it in once. So I only have to think through it one time. My chart didn't like that. And then I can drag the formula down, I can drag it over, and now we'll see how much time I've saved instead of hand entering that formula all those times. And if you want to go back into these examples and play with that yourself, you're more than welcome to with those references. When I'm typing, just so you guys know, there's a shortcut you might want to write down. If you reference a cell like by clicking on it, so say I clicked on B5, if you hit F4, you'll cycle through all the iterations of absolute references. So the first time you hit F4, you get both column and row absolute. If you hit F4 again, you get row absolute. If you hit it again, you get column absolute, and then you can go back to both relative. So F4 is the trick there, instead of typing in the $signs. Okay, finally, so here's what they did. They took their years. They use this formula here, which basically takes the year before, multiplies it by inflation. So 1 plus 2.4% in this case, which is fixed on row 10. And then you can drag that formula down and over, which they've already done. And again, not having to hand type all those formulas. And then they did the same thing for labor. So they took the year prior and then multiplied it by 1 plus 1.5%. And then it just each year builds off of the year before. So for example, this one takes the year prior, which was year 1, since we're in year 2 now, and then multiplies it by the inflated rate. Same thing here. So they've created this simple table. This is nice, but we could still, this is still a little bit hard to look at. So they created a table. And the way to do this, not a table, sorry, a chart. So the way they did this is they went to insert. So we'll select the data that we want, in this case, including our titles, our variable names, Cherry and Oak. If you include those, the Excel is smart enough and it will label your lines appropriately. So otherwise it'll just give them like generic labels, and we don't want that. So we're going to go up here to a line chart. We're going to pick a line chart with markers, and you'll see right now, so it's the same chart, but this chart looks a little bit better. Once you create a chart, there's a couple of things you need to do. You need to make sure the chart title tells you what you're looking at. If you turn in a chart that just says chart title, no one's gonna know what they're looking at. In this case, we don't really need, in my opinion, we don't need a label for the dollars on the side, because we know that these are dollars, just the way that they're labeled. Like, we don't need to know what this axis is. We know it's money. I mean, I suppose you could put an axis label in here that says US dollars, but if I want to add a chart element, I do want, let's see, and you can play around with these and see what options you have. So you can actually get rid of the chart title altogether. Okay, I want my horizontal axis title because I want people to know that this means years from now. Otherwise, that's not really intuitive, right? It's 1 through 7. Is that months? Is it days? So we're going to say years from now so people know what they're looking at. And then this goes from 0 to 600. So it's really hard to kind of see the difference between these two. So if we want to change our grid lines, we can right click on the axis and we can format it. And we don't need to start at 0. We can start at 300, I suppose. And we can stop at what they have it at 550. You can change the units that you increment by. I'm actually going to leave them at 50 though. If you were to change it to like 100, you'd see there's much less granularity, so that's not enough. So we're going to put that back. And then I think in this case, this is all we need to mess with. So now we have, you know, a little bit, we can kind of see those two lines diverging a little bit better. We can see our projected bookshelf costs. This is not the most exciting information, but I just want you guys to see how we're get used to like how I'm creating charts in Excel and how I'm manipulating them, adding and changing elements. So, okay, so we're done here. The next example is we're going to work somewhere with range names, and we're going to do some fun stuff with one-way data tables and goal stakes. So this is where I think Excel becomes extremely useful. Let's see, quality sweaters. Break even. Okay, I know this is a lot, you guys. Again, we're recording so you can come back to the harder stuff and take a look. Okay, so they've given us this information here already. They're trying to figure out basically, you know, how to maximize their profit. So they have some costs for printing and mailing of catalogs, and then how many they've mailed, which is a decision variable. So that's kind of up to the company. And then what the average order is, the variable cost per order. They've got a response rate here. So that means like for every 100 that you mail out, 8% respond. So this calculation here is the number mailed times the response rate gets you the number of responses. That's why they named their ranges really nicely. So you can see this formula, it makes sense to us, right? It's very clear. The revenue is going to be the number of responses times the average order. So those 8,000 on average order $40 each, that gives you your revenue. The fixed cost of printing never changes. The variable cost of printing is the cost of printing a mailing that varies times the number mailed. The total variable cost of orders is the number of responses times the variable cost per order. So the actual number of orders or responses, that 8,000 times the variable cost per order. And that gives us the total cost. Fixed cost of printing, total variable cost of printing, and then total variable cost of the order. So our profit is going to be total revenue minus total cost. Okay, so now we know what we're looking at. The whole point of this exercise is actually to do something really cool right here. All right, let's say that I want to know how my profit changes based on different response rates. Because right now we have a response rate of 8. There's a feature in Excel called a one-way data table, and it's really, really handy. So the way you set one up for a one-way data table is you take one column for what you want to change, which in this case, we want to see how profit changes according to the response rate. So response rate, and then what are we calculating, which is profit. We put in at the top, we leave this cell blank and we put in our profit form, and you have to call your formula. So this is calling this cell right here, which has this formula, total revenue minus total cost. Okay. They've put in, they want to know from 1 to 10%, how does profit change? So the way we do this, okay, we're going to highlight A17 through B27. We go up here to data. This data tab has some interesting things going on, but this section right here is what we really care about for this first part of our work. What if data table? Now, in this case, I'm only changing the column input, and I want my column input to be, let's see, my profit. And then, oh, it didn't like that. Hang on just a second. Oh, no, yeah. B17. Actually, I think it's this right here. I want it to go to the profit cell. There we go. And no, sorry guys, that's not helpful. Data table. Oh, I'm sorry. I don't want to include this. I don't, it's confused because I selected the wrong criteria. So for my table, I just want to select the cells where I'm going to be calculating, and I don't want to, I was creating a circular reference by including this calculation in that. This is already like our profit formula. So I just had the wrong selection. I'm sorry about that. So we're changing profit. Oh, it's actually the first time I've done this in front of other people, and it makes me nervous, so I'm sorry. Okay, we're changing the response rate, not the profit. The profit is what we're calculating. So the response rate 1 through 10 here. And we're actually going to call the fixed. Oh, and now it doesn't like me because I made it angry. I'm sorry. Let's just reopen this. Okay. I don't know what I did to break it, but that should work normally. Maybe because this file already made a data table here, it doesn't like that I'm trying to overwrite it. But yeah, so you would set this up. When you first set this up, it would be, I did this earlier and it worked. I'm really sorry. It doesn't look good for me when Excel fails me. But so you put your target here, the thing you're changing here, the response rate. It would look like this. We would not have made a data table yet. And then we're changing the column input cell. Maybe if I just do it this way, it will work. Still didn't like it. Wonder why. Okay, I'm sorry guys. I'll have to look into why this stopped working. Oh, there it goes. Okay, I don't know why. It just cleared everything and started over. That was strange. Okay, so all it did is it took this 1% and then it plugged it into the profit formula. It like recalculated all of our stuff for if that was 1%, then it did it again for 2%. The reason that this looks like this is because it's, and that's why we were getting some weirdness with the, like why it was yelling at me, like you can't change an element that already exists. Once you create a one-way data table, it's kind of picky because it's tied to so many things going on in the background. So ignore this formula, but that's what's happening here. So it's just substituting in this. And so instead of you sitting here, changing this to 7, and then recording the result, and then, you know, changing it back, and then recording the new result, it just does it for you for those values. So now we have this nice little table of profit versus our response rate. And you can see like when we got to 8%, it matches the 17,400. So we know it's calculating correctly. And then we can insert, looks like they did a, let's see. There's a lot of charts you can use. I was just looking for, I think they did a chart, and then they added a line and their profit, they added their chart title. In this case, they wanted people to know that this was, so you have to go back up here, add your titles. And then you would kind of clean up your chart and so on. Okay, the other thing that they show you in this chart is this thing called GoalSeek. And GoalSeek is, you may never use this, so don't get too worked up about this, but what we're doing is we want to take an equation and we want to figure out, like, okay, we know how to calculate profit, right? But what response rate gets us to 0 profit? So like, what's the minimum response rate we need to break even? Like, we're not going to lose money. So to do that, you go back to data, back to what if, back to GoalSeek. And then we are going to set the profit right here to 0 by changing the response rate. And when it calculates this out, it's thinking, I found a solution. about 6%, actually 5.78% if you look up here. So that's what it did. It changed the response rate until profit became 0, and then it gave us the answer. Kind of a cool feature. Okay, and then one other thing that this example talks about really quick is with formulas, you can trace precedence and you can trace dependence. Let's remove all those. So dependent tells you what other formulas use this. So profit uses total cost, but that's it. That's why there's that tiny little arrow there. Precedents tell you what feeds into this formula. So this total cost, it takes in these 3 cells, which we already knew. Sorry, this isn't a very interesting example. Let's do this. Okay, so this revenue formula takes in number of responses and average order. So it's just like visually showing you where elements of the formula are coming from. I don't use that very often at work, but sometimes I get a formula that's like a little wonky and I'm like, let me see where the inputs are, and I want that visual look. So that's what that is. I just wanted to show you guys that that it's that functionality since it's there. Okay, I know we're due for a break and we're running over, so let me just get through. We have 2 more examples in this chapter. I think the other examples will go a lot faster. So I'm going to just power through these 2 and then we'll take a break and I'll just adjust the schedule for the rest of the class. Okay, so really quickly, the next sort of thing in this one, the takeaway I just want you guys to learn from this spreadsheet, and you can go through the example in your stuff, that's example 1.4, is that you can create a named range, which is not just a cell, by selecting multiple items. So in this case, what did they do here? They had a range D5 to D9. Oh, okay. So they made this little table and they named the whole table cost lookup. So you can select like a table and you can name it, and then it will refer to that whole range in future formulas instead of just referring to one cell. They did it again with probabilities down here. Probabilities, see how it changes up here? That whole range is called probabilities and it references B35 through J35. And then I think they did it again. Oh, nope, they did not, just probabilities. Okay, so there's a couple of formulas in here that they want you guys to know about. The formulas they want you to know are, okay, there's another if, VLOOKUP. VLOOKUP is a very useful formula. So if we have a table that tells us like, this is a quantity discount table. So if you have at least some number, then your unit cost changes. So after 1,000, you go down $1. After 2,000, you go down another 75 cents, and so on. So for this case, it's doing a VLOOKUP to calculate cost, where it's going to look at the order quantity, which is 2,500. That's the lookup value. So we're looking at order quantity. We are looking at this table, which this whole table they named cost lookup. And we're looking at the second column is the corresponding value that we want to pull. So it's going to take 2,500. It's going to look it through here. It's going to find the closest match because we haven't set this to false. So it's not looking for an exact match. It's looking for the closest match. And then it's going to find the 2,000 and it's going to pull that value. And then it's going to multiply it by the order quantity. So just to show you what that means, if we change this to 1,000, it changes the cost because it pulls this $23 and then multiplies it by the quantity. So that's why you get 23,000 of the cost. So that's an extremely useful feature. If you have a table of values and something like one of your variables will change depending on that value. So that's what that VLOOKUP function does. Another function in here if I can find it. Min. So min finds the minimum of something. So we want the minimum order quantity or demand. So in this, it's basically saying which one is smaller. Is the order quantity smaller or is the demand smaller? And then it's going to take the smallest value of those two. You can also do min over a range. So if you have like a column full of numbers, you can just select all those and say min, and it will find the minimum. And you'll see that in later examples. But in this case, it wants to know between these two, which one is smaller. So in this case, demand was smaller, so that's the value that it returns. This is an if statement that says if the quantity is greater than the demand, the value of true is quantity minus demand. That's what's left over. If that's not true, then there's nothing left over. So 0 for the false. And then it does this, you know, kind of the same calculation we were doing before, where you have with the basketball t-shirts, where if there's some left over, they get sold at a discount. And then your total profit. So, okay, I'm nervous about this because it didn't like it when I did this before. But we're gonna, actually, I'm not gonna clear it because it didn't like that last time. Okay, so this is a two-way data table. So in this case, not only do we want to watch profit, which is right here. So this is how you set up a two-way data table. Your calculated function is here in the top left corner. And whatever you're changing going down, let's see, along the side is quantity. So from 500 to 4,500, and then we want to look at demand. So how does profit change with various amounts of order quantity and order demand? So we would select our region here, go to what if, back to data table, and this time we have row and column changing. So let's see, we have quantity is the column and demand. So demand is the row, the column is quantity. And then, yeah, it doesn't, if I had cleared everything out like I did before, it would populate this data table like it did before. So it's just telling us, like, if demand and quantity are 500, our profit is 3,000, and so on. So we kind of created like this nice table very quickly that varies different parts of our formula. The last thing I want to show you, so they go through this hypothetical, like, let's say we have demand probabilities, and all this means is that there's, you know, a very small chance that demand will be 500. There's like a 5% chance it'll be 1,000, 15% that it'll be 1,500, and let's just pretend that the person doing the spreadsheet had data that told them kind of the, you know, the probabilities for different ordering amounts, so that they all add up to 100 though. So all they're doing here is they want to know kind of what the expected profit is for 500. So what that means is we would take the so if we order 500 and the demand is 500, but there's only a small chance of that. So we need to do this calculation where we take this amount, this 3,000, and multiply it by this percentage, then add 3,000 times this percentage plus 3,000 times this percentage, and so on. And that will actually tell us for the order quantity what our expected profit would be. Because we know the demand, you know, is a little bit variable. So we're going based off of these probabilities. So let's look at a slightly more interesting. So the way they set this up is they use this thing called sum product, which will save you from writing out this times this plus this times this plus this times this a million times. So all it does is it takes one array, which is this right here, B23 through J23, and then multiplies it by this right here. They have to be the same size. So if it's 10 rows across, has to be 10 rows across for both arrays. If you do a column times a column, they have to be, you know, if it's 5 down, multiplied by 5 down, otherwise it won't work because it needs to match exactly. So it's going to take the first element of this array, multiply it by the first element of this array, add this times this, add this times this. That's what the sum product means. And then once you do that, you just drag it down and it calculates for all of our order quantities. So then we can see that, you know, the ideal order quantity is 2,000. That's the highest profit in this thing. And what I think what they did here is they used something conditional formatting, which they talk about in the example. And then they just took this and made a bar chart, which is up here in the histogram section. Actually, no, I lied. This is a column chart. So order quantity, actually, what did they do? Another way to see what data is in a chart or change it is to do what I just did and right click and then click select data and see it showing me order quantity and expected profit. And then let's see. Okay, so they chose the clustered column for this. So you can see instead of using these little carrots, you can also change chart type by opening up and seeing there's like a lot of stuff in here. Most of those are pretty advanced and you wouldn't use very often. Okay, and then finally, another chart type that I want to cover really quickly is scatter plots. And we're going to use this one. So they have this pricing and demand, and they wanted to figure out if there was a relationship between the two things for golf clubs. So if the price changes, does the demand for that change? Interesting. So what they did is they just created different scatter plots. And again, you go to insert. We're creating a scatter plot now. So we're going to do scatter. I don't want to waste too much time, but so let's see, we're going to shrink our axes a little bit. We're going to start at 40 just to get something a little bit better to look at. And then I'm going to change this axis as well because we don't have any values that go below 280. So, okay. I'm not going to mess with the chart title and stuff. I just wanted to show you guys what they did in this example. And there's some math in here that I really don't need you guys to worry about, is they wanted to see if there was a relationship. And so they're looking at different trend lines. The way you add a trend line to data is you right click on one of the data points and add a trend line. It pops up this menu and you can play with linear. They tried linear. They tried one, they just copied the chart, changed the trend line to exponential, and then they copy pasted the chart and changed it to power. So you get the 3. And then I always recommend you display the equation on the chart. And honestly, if this were me, go back to the chart. Trend line. I always display the R squared as well. They did some other wacky stuff to figure out which of these is the best fit. Don't worry about this math. If you want to look at like how they did these formulas, you're welcome to see that exponent function. Actually, to do exponents in Excel, you have to use this function here. Which I'll show you something really quick before we go to break about functions and how to figure them out. Oh, look, I just pulled up the help for it, actually. Bottom line from all these calculations was that the power function had the least amount of error and the best fit. You could have figured that out though, just by doing what most of us in the field would have done, which is by looking at the R-squared values and finding the highest one. So that's like a stats thing, but see this value is 90% and this one's 96. So this is a better fit. All that R-squared is telling you is how much variability in the data is accounted for by adding that trend line. So the higher that number is, or the closer it is to 1, the better. Okay, so then they just took this information from these formulas. So this is AX plus B, and the math, the textbook will kind of go over these formulas for these equations, but they each have an intercept and a slope, or for this equation, there's a constant, which is this number plus some exponent, which is the negative 1.908. So what they did is they pulled the information from that equation from this chart over the best fitting one over here to model profit. And in this table, the only takeaway when you walk through this example that I want you guys to focus on, notice how they use the max function from this table down here, where they vary the unit price and calculated profit. So again, they use that one-way data table feature. And this is an interesting formula. This is what we call an index match. And all this is doing is it's saying from this unit price table, this set of information, find this value here. Oops, I clicked out of it. Find this maximum profit value that's in this range. It has to be an exact match. And then tell me the corresponding value in this column. That's all it's doing. So it found the maximum, and then it's telling you the corresponding unit price value. So you can study that a little bit closer. Index match is kind of weird, but can be really useful for stuff like that. So pull up the example and look at it. And then you can look at like their conditional formatting and some of their notes here, but they basically created a two-way table and looked at profit versus unit cost. So I don't want you to get too hung up on the math and stuff, but definitely go into these examples and play around, especially this one, since we didn't go through it in quite as much detail. So, okay, I know we're behind. I kind of figured that would happen. So we're going to take a break. Let me see how much I've messed up our schedule here. Okay, pretty badly. Let's come back at 2:25, and we'll just kind of, hopefully if you guys have questions, you're kind of saving them. We'll go through the next section, which is a lot shorter, and then we'll take another break, and then we'll finish up. So I'll see you guys back in like 7 minutes. Okay.
Sounds good.
Here we go. All right, I finally got the thing to start presenting the way I want it to. Okay, so this next part moves into chapter 2, which the concepts here are really just aimed at presenting data in like simple forms. So bar charts, pie charts, which I don't recommend really ever, histograms, the scatter plot. So some of those things we kind of did through our last examples, just hammering those things home. And then how do you do like counts, percentages, some more complicated averages and statistical calculations, and then tables. So that's tables and pivot tables. So when we're doing data analysis, there's 4 steps involved. We want to recognize the problem that needs to be solved. And this actually is like a whole course in and of itself. Gather the data to help solve that problem, analyze it, and then act on that recommendation. So when we talk about data, you're going to hear some important terms that you're going to need to understand the difference between for this class and all future analytics classes. The difference between a population and a sample, between variables and observations, and then about different types of data. So there's like categorical, nominal, and ordinal. And the reading covered all these definitions. But a population is all entities of interest in a study. So that could be like all the voters in a presidential election, or every invoice that was submitted for Medicare reimbursement by nursing homes. It really depends on what your problem is. That will tell you what population of data you're seeking. However, generally you can't get data on every member of the population. So if we're looking at potential voters in a presidential election, we're not going to get data on every single voter. So a sample is a subset of the population for which we use to represent the population as a whole. And because we are, that's called inferential statistics. So we're inferring information about a population based on a sample. That means our sample needs to be representative of the population, which means in general, we want our sample to be randomly chosen. That way there's no bias in our sample. But you'll find when you look at studies, or if people like give you information about a poll, always look at how they collected their sample, because for example, presidential election polls often collect their samples via landlines. Well, that may not necessarily be an accurate representation of the entire voting population, because how many of us have landlines? What types of people have landlines? Are they from skewed toward a certain age demographic, or like a certain regional demographic? Maybe they're more rural. So you have to kind of think about those things. But ideally, our sample would represent our population. So if I'm doing a study on sales transactions in the past year for a company, I may not pull every single record. I may randomly pull like 10,000 records, and I would just use a random generator to go in and just pull randomly 10,000, and that would skew correctly based on every, so like if there tends to be more orders in December, I should see a higher percentage of December orders in my randomly generated sample. Okay, one sec, you guys. I have okay, sorry about that. Spring break. Okay, so a data set is generally like what we consider, you know, our the data that we get in our format. So it's just a rectangular array of data. We have our variables in columns, and then our observations are in the rows, and we'll take a look at that in a second. So variable is a characteristic of a member of a population, and an observation is all the variable values for a single member. So if we look at a spreadsheet, this data set has 30 people, and we're only looking at 10. They responded to a questionnaire. So the variables about those people include age, their gender, their state, how many children they have, their salary, and what their opinion was. The rows, so for person 1, 2, 3, 4, 5, that includes all of the variable information about each member of that population. So this is how we like to see our data, variables across numbers down the rows. If a variable is numeric, we can do stuff with it. We can do stuff with non-numeric data too, but we have to usually manipulate it a little bit. So if it's non-numeric, it's categorical. And then we have dates, and there's a lot of funny names about Excel and dates out there. Maybe I'll post one later. But Excel treats dates as numbers, but sort of not numbers. And so weird things can happen sometimes when we're manipulating dates. But the date variable is important because it will help Excel recognize when you're doing some time series forecasting instead of just scatter plotting. Ideally, if it's artificial intelligence is working correctly. So a categorical variable is ordinal if there's a natural ordering to its values. And if there's no natural ordering, then we call it nominal. So like ordinal would be like best to worst, or like first to last, or tallest to shortest. There's a specific ordering. So, and then no natural ordering would just be, you know, like age, or yeah, like, or height, or like number of children. It's just a value. Okay, so if we have a categorical variable, we can make it numerical by assigning it a dummy variable. And a dummy variable is binary, so like 0 to 1. So if you take, for example, like the gender field, it might be categorical because it says male, female. So those are non-numerical values, but we could code all the males as 1s and all the females as 0s, or all the females as 1s and all the males as 0s. And that's basically saying, you know, 1 is this thing and 0 is the other. So that's one way to code a numerical, or a categorical variable. We could also bin, which is basically, instead of doing 0 or 1, we create like bins for that data. So in this example, they have these opinions, strongly agree, strongly disagree, and that we can't do anything with. But if we code strongly agree as a 5, so this is going to be ordinal because it matters, the order matters. 4 is agree, 3 is neutral, 2 all the way to strongly disagree. We could actually do a VLOOKUP. We could say VLOOKUP, look up the value of strongly agree, find it in this table, and then give me the corresponding number. And actually, I think to do that, you would have to move these numbers over to the side, which is interesting that they set it up this way. But so we could use our VLOOKUP formula, and we could create a new column that says like opinion value. And now we have numbers in there, and we can do something with that. So we could look and see like what's the average opinion rating for middle-aged versus elderly, or what other information, gender. And you can see in here, they took the gender variable and they dummy coded it to male or female. I think in this case, males are 1s. And then, and so that they could very quickly figure out like what percentage of this total population is male, percentage is female. Okay, so if the variable is discrete, if it's like a count. So number of children is discrete. Nobody has a third of a child running around, hopefully. So that's like things that are counted in fixed numbers. Continuous could, you know, you can have decimals, so weight, height, those things are continuous. They use the word cross-sectional, which is just data on a cross-section of a population at a very specific point in time. And then time series data is data collected over a fixed period. So for example, actually don't know what they want you to take away from this, to be honest. This is quarterly data. I think they're just showing you time series data. What you would do with this, you'd probably want to reformat this into something a little easier to work with. But yeah, so they're just showing you this is time series data. It's quarterly observations on revenues from toy sales over a 4-year period. And they did do it chronologically. So Q1 2015 through Q4, and then we moved to Q1 of 2016, so on and so forth. So with time series data, we can do time series graphs, which we'll look at in a little bit. So with categorical variables, we can't do a whole lot like with that whole like male, female, or elderly, middle-aged. We can count in each category, and that's about it. So by doing that, you're basically going to get histograms or pie charts. So let's look at supermarket sales. Let me just make sure I'm about to open up the right, file. Okay. So it's funny that they put this note in here because it's not relevant right now. Here's a bunch of data. So all of our variables are across the top. Note, column A is generally like an ID column, or what we call an index, which helps us just identify each unique member in the population. So purchase date, we're not going to do anything with it. Basically, is what I'm saying. Like it doesn't add any information. So we have date, and then we have the customer ID, which again, not useful information. Gender, marital status. So it looks like they could be either single or married. No polyamory, it looks like. So that could potentially be dummy coded 0, 1, same with gender. Homeowner is another potential dummy variable because it's yes, no. So you could say homeowners are whens, and we would just do like a, actually to quickly create a dummy column. You can insert a column, which you saw me just right click insert. And then I could say if this is yes, then give me a 1, otherwise give me a 0. And then I can take this formula, drag it down to my last observation, which, okay, so I could do it this way, but actually I'm going to show you another trick because this is also tedious. I could control copy this formula, and then if you control shift and press down arrow, it will take you, it didn't do it because I partially filled in. If I hadn't partially filled in, it would have taken me all the way to my last observation. And I regret doing this. Let's clear this out and see if it'll let me do it again. So if this is Y, 1, if not 0, nope, that was my bad typing. There we go. So let's see if it'll let me do it. I'm going to copy this, control shift down. Did not work. All right, well, anyway, so you could drag it down, copy paste. What happened there is it's not recognizing this data as a table right now, so it took me all the way to the very last possible row in the spreadsheet. We can fix that, but we'll talk about it later. We'll format data as a table, and then when we do that, it will only take us to the bottom of the table, and then we would have control pasted our formula and been good to go. Okay, so there's some other stuff in here, some categorical values like food, drink, non-consumable, product department is categorical, units sold, revenue. Okay, so what they want to show you here is some formulas, and that's really it. They want to show you how to do countifs. So in this case, we had male or female, no dummy variable in there. So they said countifs. So they selected all these values in this column, and another way to do this, you can actually just, instead of selecting down, we could just do this, the whole column. And then we want to know if it equals M. And count. So it's just going to go through that whole column, find all the M's and count the instances. And then we could pull this formula down and it will be fine because this is not an absolute reference, but since I'm not moving over columns, it'll be fine. And then it will reference the F instead of the M, right? Because it was a relative reference. So it pulled my R3 down to R4. So COUNTIFs, they did it for married, they did it for homeowner. They were just trying to figure out, based on this sample, what percentage is male, female, what percentage is married, non-married, and what percentage are homeowners. So then for that calculation, they just took it's funny to me the way they did this. So like any percentage, the number of males over the total of males plus females. That's what that sum formula is for. And then same thing here. Notice they made this sum reference absolute so that they could just drag this formula down and it would calculate with this value, but still be the sum of these two. So they did that for all of these. And then the other takeaway from here, they also did it for the annual incomes. And then they just created some charts. So these are histograms, male, female. But what they wanted you to notice here, okay, so when you're doing charts with data like this can be a little misleading. So notice the scales between these two. So this one, the axis is set to be like a short window. So it makes the difference between male and female look pretty large. But if you were to set this scale to be this axis to have a bigger scale from 0 to 8,000, you can barely notice the difference, which is actually more accurate because it's almost exactly 50-50%. Same thing if you were to show these as percentages, male, female, and then percentages, see that data selected. By changing this to 48 to 52%, it makes that gap look a lot bigger versus the 0 to 60%. So be mindful of your scales. People will manipulate scales in charts all the time to make their case look more compelling. So don't cheat. And if you're looking at charts and you're like, that's interesting, always look at the axis and see what the scale is. And then pie charts don't really allow you to do that. So you can see like whether you do it by count or by percent, since it's a pie chart, it's fixed out of the whole, it'll look the same. Yeah, I just laugh when I see pie charts. So the pie chart feature is right here. So you can just select your data and then insert the pie chart. Okay, all right. Okay, so numerical variables we can do a lot more with. Something like salary, we can look at salary, we can say like, what's the most typical salary? How spread out are they? Like, what's the range of salaries? Are there any outliers or extreme salaries on either end? Is our salaries normally distributed, or are they skewed right or left? Or do they have any other peculiar features? So we're gonna in our next examples look at salary compared to other variables, and we're gonna look at some measures of central tendency, min max, which we've talked about before. We'll talk about percentiles and quartiles. We'll talk about how to measure variability and standard deviation. I don't want you to get hung up on the math. These concepts are covered in the book. It's important to know what they mean, like what does that mean, the standard deviation, but not how to derive it, if that makes sense. And Excel will calculate it for you. So if you know how to use the formula, you know how to get the number. And then if you know what standard deviation means, you know how to apply it and no math is involved. And then and by shape, they mean, is it normally distributed? Meaning, you know, is the data nicely distributed where it falls around the average and then falls away to the outer ends of that distribution, or is it skewed or to the right or left? So we're going to take this baseball data. Looks like I have and I wish they hadn't done this. Okay, so they have these players, the team they play for, and they put the graph right over our data. So let's move this. 1 second, guys. Okay, so they like all they're doing in this table, I think there's actually, this isn't the one that I want. Here we go. Okay, so they have the, whoa. Might have, that's weird. My tabs disappeared. I might have too many files open. Let's try that again. Okay. Player name, the team, their position, and their salary. So this is a lot simpler of a data set. So the initial look at their data, they took all this information and they made a histogram. It looks like they let Excel. Okay, so they picked histogram and then they actually just let Excel like decide how it was going to bin all of the salaries. And this is not a very good graph because first of all, we can't even see what this means, but okay. So it looks like it randomly picked bins of like 545,000 to 2,845,000. 2,845,000 to 5,145,000. So I don't know what the logic was behind, but if you just generically create a histogram in Excel, it will try its best to bin stuff for you. This is just a box plot. So this is kind of an interesting look at statistical information about all these salaries. So you can see there's actually a lot of data in here. So I'm going to select the first one, Control Shift down. Now I've collected all 878 values, and then I'll insert a box plot. And I believe they're under, these things are so small. I'm looking for my statistical charts. Where are they? Box. Okay, so here's my box and whisker plot. And then all this is telling me is like how my salaries are distributed. So this little X right here is the mean. And then this is my like third and first to third quartiles, and then everything in like all these individual dots above this line right here are considered our like outliers or extreme values. So we can kind of see like where the average salary falls, but then there are some really high paid pitchers, which if intuitively, if you know anything about baseball, that probably makes sense. A lot of like mid, okay pitchers on okay teams are paid about the same, and then there's some superstar pitchers that are paid a lot more. So the text goes into what these things mean. The mean is just the average. That's the mathematical formula for it. I believe most of you are familiar with the concept of an average. It's just the sum of all the values divided by the number of values. So in Excel, we use the average function. So we just say equals average and select the numbers, the data set that we want to calculate the average of. The median is the middle observation. So if you sorted all the values from smallest to largest, it would be that middle observation. If it's odd, it's literally, if there's an odd number, like 5 observations, then the third observation from smallest to largest is the median. If there's 6 observations, it's the average of the third and the fourth. And we use median as a function in Excel. Mode, we don't use a lot, but it just means the most, a value that appears the most often. So if you think back to that information about people who had like number of children, you might be curious to know like which amount of children shows up most often. Like, is it 2 or 3? It's probably 2 or 3. So you could do mode on the data values for a number of children for a data set and see what it returns. You use mode, but I put a note in here for you guys to look up later. So if you use mode, you're actually using mode single, which means it's going to find the first mode that it can, and it will just spit that out. But you might have more than one mode in a data set. So because it's just referring to most, your data set might have like let's say for that number of children, the number of people who have 2 children shows up 20 times, and the number of people that have 3 children shows up 20 times. So technically there's 2 modes. If you just ran mode, it would only spit out 2. It would say 2 children shows up the most often. So mode.mult is how you get all the modes for a data set, but it's an array formula, which is a little weird. To do it, let me pull up the next data file. So let's go to here. Okay, well, this isn't really going to make a whole lot of sense, but we're going to do it anyway. So let me move this thing. For mode mult, see how it gives me this option? Okay, so I'm going to select all the salaries and I'm going to find the mode, but I'm going to assume there's more than one, which there may not be, which it might. So this is why I'm saying this may not. Okay, so before I hit enter, when you use an array formula, which there aren't very many, you actually have to do Control-Shift-Enter. And see how it adds those curly braces? That's telling you that it ran mode. Okay, so there was only one mode in this thing, so it just returned one value. But if there had been 2 or 3 modes, it would have dumped them all out. So like the next one would have shown up in this cell, and it just would have given you a list of all the modes. So just be aware of how mode works in Excel. It's a little bit wonky. Okay, we also have some measures of variability. So range is the maximum minus the minimum. That's the total spread in the data. And the interquartile range is the third quartile minus the first quartile. So quartiles just means you've broken your data up into the first 25%, 25 to 50, 50 to 75, 75 to 100. So if you're doing the third minus the first, 75 minus 25, so that mid 50% of the data. The middle of your data is less, has less extremeness than the outer ends of your data. And then variance. I don't want to get into the math on variance, but variance tells us how close all of our observations are to that average value. So if our variance is low, it means that our values are closely centered around the mean. If our variance is high, it means we have a bigger spread in our data. We can use sample variance. We're not going to get into sample and population, but we're generally working with samples. So we would use this var.s variance function if we wanted to calculate variance. And Excel will do it for us. So the formula doesn't really matter. Just remember, it's telling us the spread of our data. Higher variance is less desirable. We kind of want our variance to be close to the mean. So standard deviation is kind of another way of looking at that variance. It just has different units. Variance is in squared units, and standard deviation gets rid of that square by taking the square root of it. So we would just use standard dev.s to calculate standard deviation. So in this example, and I do encourage you to go through the book to look at the formulas if you want. They're just taking some information and they're just calculating like the mean of the diameters. So this would just be, the formula here would be equals mean, and they would have selected A4 through A13. And it would tell you the mean diameter is 100.039. The variance looks like plus or minus 9. So that's pretty low variability. I mean, it's within 10%. And then the standard deviation is the square root of the variance. So you can see that makes sense. So this is like, they consider like, here's your low variability supplier, and then here's your high variability. So on this supplier, the means are about the same, but look at the difference in their standard deviations, much, much bigger. Okay, this is just a general rule of thumb. It's kind of nice to know. So if you have a normally distributed variable, so if you have a bunch of data and you're assuming it's normally distributed, meaning your data is not wonky, it should, there's no special weirdness to your data, then about 2/3 of your observations are within one standard deviation of the mean. 95 are within 2, and then 99.7 of all your observations, so almost all your observations are going to be within 3 standard deviations of the mean. Anything that fell out between 2 or past 3 standard deviations would most likely be an outlier, and you would want to take it out. So again, if your data is skewed, like the baseball salaries, that won't really work, those rules of thumb. And I really don't want to get into this math, so none of this is stuff that you guys really need to know. Just with skewness, a variable is skewed to the right if there's some really, really large salaries. So like with baseball salaries, we have some really huge salaries that are kind of pulling our average high than it really should be. So we call that skewed right. If we had like a data set where there were some really, really unusually low values, they reference like temperatures in Antarctica, and it pulls our average to the left more than it should, we call that skewed left. And we can calculate skew, but unless you're a statistician, that calculation won't mean much to you. Not even going to get into kurtosis. again, and we're going to get back into Excel here. I just want to point those things out because if you're at your job and you need to calculate those things like standard deviation for different sample sets, Excel has the formula and it works just like all the other formulas in Excel. So that's really the big takeaway that I want you guys to get out of this for now. So for histograms, okay. I showed you guys how to create that histogram before, and I showed you guys how to do the box plots. So now we're going to look at time series graphs really quickly, which are not really any different than a scatter plot. Just the key takeaway here. Let me get rid of this. So, sorry, one other thing. When you're looking at box plots, we looked at like all the salaries. We could also kind of separate this stuff out by like, so like here, they did it by position. And this is where you actually can glean more information. So go through the example where they walk through the box plots and like how they interpret this graph is really interesting. It's basically saying, if you look at the averages, these X's, first baseman and designated hitters on average get paid the most, but there's a pretty wide spread. Pitchers on average don't get paid a lot, but then you have some that get paid a ton more unusually. So go through that thing. They also did some binning like pitcher, non-pitcher, Yankees, non-Yankees to see, how these things compare. So you can get like a nice visual comparison of your data and how it's spread out. And then you can even do it by segment. Okay, crime. All right, so when you pull up this sample file, they give you some directions here about creating a time series graph. I highly recommend that you go in and you just follow these directions and create one of your own. Really the big difference between the time series graphs is you're going to create a line chart, and then you're going to hope that Excel is going to recognize that you're trying to create a line chart with time series data, but it doesn't always. So they tell you how to fix when that goes wrong. So in this case, they have it by year. And when you start comparing, okay, let me see if I can zoom in, guys. This is like really small. Okay, so if you do it by just population over time, from 1960 to 2008, you just get, this sort of pretty linear increase over time. If we looked at, say, property crime as it relates to violent crime, you can plot them both. However, if you do this without two scales, a secondary axis, one of the charts will look really, really small. So if I take away the secondary axis, I kind of lose the trend in the violent crime. So by creating a secondary axis, it plots property crime according to this left axis, and then violent crime according to this right axis. And the reason I want to do that is because I'm trying to compare the trends. So the scale matters less to me than being able to see how things change over time. So just by looking at this chart with that secondary axis, I can see that property crime and violent crime are pretty closely correlated to each other. When there's more of one, looks like there tends to be more of another. Looks like they did this same exercise. Okay, so now they just plotted different types of crime over time. And then different types of theft, it looks like. And in this case, they're just trying to see how all three of these things changed over time. So they're all on the same scale. You can only do a primary and secondary axis with two variables. So in this case, the scale is retained. So there's a lower rate of motor vehicle theft in general than burglaries. And you can kind of see like larceny spiked and then decreased again, and burglary kind of followed the same trend, but motor vehicle theft rate didn't really seem to change in conjunction to the other two types of crime. But really, these are just line charts. It's just the key difference if you follow the directions is it's telling you, you know, what you can do to manipulate the time series data to see like months, or you can do it by like days, weeks, months, years. So you'll have to find the right level of granularity depending on your data. Oh, actually, none of these charts are all hidden. Okay, so I mentioned outliers a little bit. Those are values that lie well outside the norm. If you have outliers in your data set, like if you're looking at some box plots and you see that, it's best to do your analysis with those data values and then with those data values removed, so you can compare and see if it drastically changes some of your observations. And then if you have missing values, there's a couple of options. This is common in data sets to find missing values. You can ignore them. Excel just ignores them as well. So like if you do an average and there's some missing values and the cells are blank, they just won't get factored into the calculation. They won't get treated as zeros or anything weird. It won't mess up their calculation. But it is important to make sure that that's how, if you're not using Excel, for example, how it would handle that. You could fill them in with an average of all the non-missing values. Not a great solution, but sometimes it works. Or you can examine the non-missing values and then base them off of values in another row, like a similar observation. Okay, so let's talk about tables. I'm just going to show you all these features, and then we'll kind of just move along to the other examples because we won't have time to stop again. So, okay, catalog, marketing. Okay, so this data is formatted as a table. Let me actually take it. Out of table format here for a second. Okay, so trying to see if I can do this. Oh, here. Okay, so I'm gonna once you have a table, if you don't want it to be a table anymore, you can convert it to a range. When I did that, I lost my table tool, so now I just have data again. It did leave the color coding formatting, but this is no longer a table. So if I want to format data as a table, I would select my data, which is already selected, format as table, and then I can pick whatever. And I'm telling it, my table has headers. So I already named my variables at the top. Okay. Nope, it wants to give me ideas. No, thank you. Sometimes the software is too smart. Okay, when you convert something to a table, you get a bunch of functionality, and you can play with this, but I just wanted to show you guys what you get. This new ribbon up here called table design. You can now sort. I can sort by age, smallest to largest, largest to smallest. I can filter out. So if I only want to look at married people, I think married is one, I can filter my table. And then I can clear this filter by clicking clear filter. If I have a numerical value, I can sort, sorry, one second. I could only look at people in California. I think you guys get the point. You can also do filters this way. You could say equals, or if it's all the states that start with the letter C, I don't know why you would want to do that, but just to show you the sort of functionality. Another thing you can do with tables is okay, so here's how you change the table design. You can add a total row, which it's not understanding my request there. That's okay. You can also, let's see. If I add a new variable up here, Excel's really smart. So it says, okay, she's adding to this table, she's appending a new column. So notice how it already like added for me. I can add a calculation, like I want to calculate the average amount. Well, that's actually not what this would be. Let's do, okay, so I'm going to calculate how much of this was spent over, oops, let me start over. This over and then I just hit Control Shift down, the total amount spent. So, and then it's treating it like dollars. So I have to tell it, no, this is a percentage. Okay, so that's not really a meaningful calculation. I just wanted to show you guys that when you have a table, Excel kind of understands when you're trying to add like calculated columns. And then when you do that, notice my calculation, instead of referencing the cell, it's referencing, it took the amount spent for that row, which it uses a weird syntax, divided by the total amount spent. So it's a little smarter. It already named your ranges for you based on your table headings. And so it will adjust your calculations for you. So that's pretty cool. There's other stuff you can do in tables, but I mean, that's kind of the key gist of it. Yeah, I thought, okay, so I think from here, we're just gonna go on to kind of the last couple of things, which are expanding on what we just talked about. So we're interested in if we're interested in like relationships between variables. So when I talked about cost estimating, I talked about like weight and cost and how those things are related. We generally want to use a scatter plot for that. And we saw where the scatter plot function was in the chart graph, but we can also create different kinds of tables. So they created what's called like a crosstab, which let's see, smoking and drinking. So if they have, information on all these people and whether they smoke, so I think this is like no smoking, occasionally smoking, heavy smoking, occasionally drinking, heavy drinking. They used a count ifs formula, which is a lot like the count if, but it's a little more, it has more than one criteria. So in this case, their count ifs are saying if count if all the smokers that are, all the drinkers that are ND in this column, and then smokers that are NS. So you can see criteria range 1 is column B, the smoking column, and then F3, which is NS. So if it equals NS, and then of the drinking column, if they equal ND, count. So they have to meet both criteria in order for it to get counted. That's just the additional functionality of count ifs versus count if. Count if is one criteria, and count ifs is multiple. And you can add 3, 4, or 5 criteria if you want, but in this case 2. So they created their absolute references the way they need them, and they drag this down and over. You can study those if you want later. And then this is what we call like a crosstab table. So it's just comparing something down and across. And then they ended up creating some column charts of those things. So this one is the percentage of non-drinkers who are also non-smokers, occasional drinkers who are non-smokers, and heavy drinkers who are non-smokers. And then of occasional smokers, non-drinkers, occasional drinkers, heavy drinkers, and then for heavy smokers. And then in this case, these are just different. So they did it by the row totals here, and then they did it by the column totals here. And to switch, you just go to, oh yeah, so they calculated across, and then here they calculated down. So you can kind of look at those if you want to decipher them a little bit differently, but it's just two different ways of looking at the data. So, okay, so those are crosstab tables. There's a better way to do this. Sorry, some of these. Okay, so if you, so that was what they used that methodology because you were comparing two categorical variables against each other. So really all you can do, as we talked about before, is like counts. If we want to, I'm going to skip over the stacked and unstacked because it's a stat tools thing, but so if we want to look at some summary measures for a lot of data, how did we get back to here? Okay. We can also compare among numeric variables. So if we're comparing two numeric variables, then we would use a scatter plot. And once we have numeric variables, we can do a lot more. We can also calculate like correlation and covariance. So the formal definition for a scatter plot is a scatter of points where each point denotes the value for two selected variables. So your x-axis has one variable, your y-axis has the other. We're looking for relationships and we want to see them. So in this example, they use golf stats on the PGA Tour, and they took like age and they plotted it against events. They took age and they plotted it against earnings. You can see some interesting stuff going on here, but no real relationship. And they did this for a bunch of variables. And it looks like here, there might be something, but once you create those scatter plots, then if you think there's a trend, you can add a trend line, and then you can kind of analyze the equation and the R-squared and some of the information about that equation and see if that trend is meaningful. And then these concepts of correlation and covariance measure the strength of that direction and of that linear relationship, and then how tightly those points cluster around that straight line. So if it's strong, it'll be closer to 1 or -1, depending on if it's a positive relationship. So as x increases, y increases, or negative. So as x increases, y decreases, or as y increases, x decreases. Okay. There are functions to calculate those things. The correlation one is really the one that we're looking for. So if you have some data, and this is kind of cool. So we have all this data, right, about golfers, and we want to figure out if there's any relationships between like any of these variables. Before we start plotting like crazy, we're just gonna take all of our, we're gonna calculate correlations. So they took all their variables down, and then they also pasted them across. And a quick way to do this is you can take all your variables in one direction and then paste transpose, and then it will paste them across horizontally. So that's just a quick way to do that. Then this function here So the reason they set it up this way is so they can drag this formula down and only write it once. So correl is the function that we want. Indirect is a way for us to call age as a range. And so this is fixed on column B, and this one is fixed on, or sorry, on row B, column B, and this one's fixed on row 3. So when we drag this formula down, it just calculates for all of our things. But the reason this works, that indirect works, is because age is a named range. So if I do Control Shift down, see all the age is a named range. So that's a really clever way of saying what's the correlation for age and age. It's always going to be 1 because it's correlated with itself. So the diagonal we don't care about, but age and events, 0.08, negative 0.08 is not a great correlation. And they have this set up to custom conditionally format higher values higher than I think 0.6 or something. So we can see a strong correlation between events and rounds and like driving. So these are where we would want to start. So we would plot rounds against events and see what that looks like. And if we find it, of course, that's not one in here. Let's see, what's another good one? Rounds versus cuts made. Let's do that. Cuts made, rounds. Okay, so 0.888 is a pretty strong correlation. If we look at the scatter plot that corresponds with that, we can see like that is, we can see a relationship there. We can add a trend line and get the equation. So that's the formula for correlation. Okay, and then finally, the very last thing is pivot tables. And we could go into pivot tables pretty heavily, but I really mostly want you to self-study this yourself. And to create a pivot table, you're just going to select all your data. You can do Control Shift down and over, and then insert a pivot table, put it on a new worksheet, and then now you can drag fields and do a whole bunch of crazy stuff with your table. So I could look at, for example, gender, and let's see, like items ordered. So this is the sum of items ordered, but maybe I want to look at the average. So, you know, is there a difference between male and female average items ordered? You could do, you know, max, min, really however you like. You can add in more layers. So I could do it by region. So go ahead and go in and play with these things. I can create crosstabs very quickly with counts. So I did by gender and region, just by moving things around through columns and categories. And you can keep adding layers to these pivot tables, but I really want you guys to play with this because this is a very powerful tool. You can add grand totals and subtotals, so you can play with that. And I think, you can also go up here. So see, I've created like a chart, and then I just click pivot chart. So it took my, you know, female to male by region and created what it thinks is the chart that I want that corresponds with the table I just created. So this is a really powerful tool to quickly break down your data, segment it, you could calculate averages, all sorts of things with the functions, and get those through. So go in through, walk through that example, play with the pivot charts and tables, very good tool. And then if you have any questions about formulas, the other thing I wanted to show you guys, there's a formula library. So up here, or a function library, you can see all these functions. You can also find a function this way. So this is every possible function and it will tell you what it does. I mean, I don't use hardly, I mean, this is like so many things, but like count, counts the number of cells in a range that contains numbers. And then you can click down here for help. So if you want to learn more about a function, if you're trying to figure out how to look it up, you can go find it and then click help and it will take you to the Microsoft support page for that function. And there will be a ton of resources. So I want to make sure you guys knew how to get there. Okay, so that's it for chapters 1 through 3. I promise you future weeks are not going to look like this week. The one thing I want to do though before we close out, because this is important, and I'm really sorry that I cut most of our discussion time out. In the future, we only have one chapter at a time. We will go through the examples a little slower. There'll be more content that goes along there. It won't be so much about just basic functionality. And then we'll have our discussion and we'll talk about the discussion forums. So I'm not sure how many, I didn't see any posts yet. The way this is going to work going forward is we will talk about the discussion questions in class, and then you'll also submit kind of your general response. If you participate a lot in class, your write-up doesn't have to be super like long or detailed. It can just kind of summarize what you talked about, or kind of be your talking points. If you don't come to class or you don't contribute and you want credit, you need to do a more lengthy write-up. So if you find yourself not having much to say in class, or you were kind of confused, or you thought of things afterward, that's fine, but then just make sure that your write-up that you post to the discussion forum on Thursdays is a little more detailed so you get more credit. Okay, so our discussion was kind of based around different types of analytics, and we start with like low level, low value, descriptive. That's like the summary stuff that we talk about, like histograms and averages and things like that. Diagnostic is just like slightly more complex. It's kind of like, it's also kind of called discovery analytics. So that would be like doing a little bit more like segmentation in your data and looking at, different groups of data compared to each other. So let me get into predictive and prescriptive. And this is where I wanted you guys to tell me what you learned about what the difference is, or if you could articulate the difference between predictive analytics and prescriptive analytics. So we only have a few minutes left, but I am going to open the floor if you guys want to say anything, or if you have any questions about predictive versus prescriptive, and then I'll stay on a little bit after if you guys want to ask me about like Excel or anything, or if you need me to provide more information about a specific topic. Okay, so who wants to jump in here and talk about, did you guys, have you been able to do the discussion or look at it?
I briefly looked at it.
Okay, do you have any idea what the difference might be between predictive and prescriptive?
To my understanding, predictive is exactly kind of what the chart says, like what will happen. So if you come up with a whole bunch of data for like, let's say, how COVID was affecting retail rates in a store, it's like, okay, well, we're going to be completely sold out of toilet paper. And prescriptive would be more or less how to mitigate that happening.
Okay.
That's what I think it is.
Yeah, it's a pretty good start. So predictive is kind of taking what data exists and then using it to kind of predict a future observation. So for your COVID example, we could also take like current infection rate data and then try to predict like next week's infection rate. Prescriptive is a little trickier. Prescriptive uses machine learning and AI to make a recommendation about a path forward. Sorry for the little one here. I'm actually going to stop sharing just so you guys can see me.
Prescriptive is kind of like you were saying, like you build the artificial intelligence in there, but predictive is more so like in chapter 3, it was talking about how like DAS they implemented for strategic decisions, such as like, okay, we're going to have a Thanksgiving Day parade. We know from the last 10 years of data that these are common areas where that we might need more officers on patrol or more public safety officials kind of in this area based on what we found. And then with the prescriptive, it sounds like it's more, I know it's a newer data form and tool, but it seems like it's more based on, what we've kind of embedded into the computers and then what that AI is kind of using as that technology, correct?
Yeah, so with a good example of prescriptive that I like to use is Amazon's warehouse. So if they create an algorithm that takes in all the data about all their orders and where all those items are located and the time it takes for the robot to like move along a grid and collect each item, it will crunch all that information using AI and spit out like the optimal layout for where to put items. If you did that using human logic, you would put like items with like items. The logic that comes out of Amazon's AI says, put these things, they may not seem related at all. Like, why would I put those two items together? But according to that algorithm and all the data, that's the way for the robots to collect based on just all this order data. It predicts what the future ordering like patterns are going to be like for its customers. And it knows when people order this, they tend to also order this seemingly unrelated thing. So put them together and then it just continually optimizes that layout. So if a human looks at the layout for the Amazon warehouse, it's like, what is this? But it's the most optimal, most efficient, and the prescriptive analytics is telling you here's the best layout, just do it. It's making that recommendation. I think another prescriptive. So Boeing, there's some recommended articles. There's one about Boeing. So for, I think Tyler, you're at aviation, that talks about how they use predictive and prescriptive in their manufacturing. And there's one for healthcare about prescriptive analytics. So you could, I could do some research, but I would imagine that there might have been somebody out there that said, based on all the data about COVID and who's getting it and who's spreading it, how should you vaccinate people? And it probably doesn't look at all like how states decided to, because it may not make sense to us or seem medically ethical, right? Because what a prescriptive algorithm would come out with would be like, vaccinate these people to minimize future spread based on all this data. But decision makers are kind of going more by like, well, who's high risk and and how do we roll out in that form? So that would be the difference, I guess, or how prescriptive analytics kind of works. It doesn't take into account human logic at all. It just crunches data and optimizes it and tells you, here's how you optimize whatever function it is that you're looking at. Okay, so go ahead. I don't know if Tashi or Alina, if you want to add anything to that, or just go back and do some more research and build out your response in the discussion forum. Hear noise, but not your talking, Alina. Back on you. Okay. All right, no big deal. Okay, so go ahead and finish your course readings. Maybe find some good current examples of like predictive and prescriptive or how they're being used, and just kind of make sure that you understand the difference between those two. And like I said, next week we will have a much less information-filled lecture. So thank you guys for hanging in there. This was a lot of information. If you're still feeling overwhelmed by Excel after you go back through the examples and walk through them yourself, please reach out to me. I'm happy to do like a private Zoom or whatever you guys need to kind of get up to speed with chapters 1 through 3. And if there's anything you're like thinking right now already, like I want to know more about, go ahead and tell me, and I will get you guys more resources right away. Okay.
Hey, did you hear me speaking earlier or?
No, sorry, we didn't.
No? Oh, okay. No, I was talking about descriptive.
Oh, okay.
Yeah, I was saying that I think it's a problem with my microphone. I just unplugged it. I was saying that the descriptive one is more for the historical data of a company, so you can see the past instead of when prescriptive will not, yeah, will look at the future of the company, and you can predictive, sorry, you can predict events based on the data that you have, but the descriptive one looks at the past more than the future.
Yeah, that's right. Awesome. Thank you. That's a good point. That's one of the key differences between the two. So that's great. One is definitely backward looking, and then one is more forward looking. Okay, guys, I'm gonna let you go because we're over. I'm really sorry. I really would like for more discussion. So next time I'll make sure we have ample time to kind of have a class discussion. Yeah, reach out to me, text or email. If it's more urgent, send me a text. I would start your homework early so you're not scrambling on Thursday, since you know, if you send me a note on Thursday afternoon because you're stuck, I may or may not get to you in time for submission of the assignment by Thursday night. Because I do have, you know, I am a mom, and it's my weekend too. So I'll try my best to get back to you as quick as possible. If you're like really, really stuck, I know you guys have lives and jobs and families and other things going on, and weekends are really the ideal time for most people to do their work. Then I can always grant an extension. So I don't ever want you guys to get to the point where you're so stressed out trying to do your homework and you're spending a lot of time stuck on one problem. Just set it aside, send me an email, and don't stress about it any longer until I get back to you. Even if I don't get back to you until like the next morning, don't think I'm gonna like get on you for, you know, being late. That's on me to give me some time to get back to you, and I'll let you know like, hey, you're good for another day or two. Like I'll help you figure it out. So yeah, I've had students before like spend way too much time on a problem trying to get it in when they could have just reached out to me. So I don't want you guys to do that. Okay. Okay, do you guys have any other questions for me?
Yeah, I have a question.
Okay.
So, so the discussion board question is due today?
Yeah, so the way the discussion boards work, they're always due on Thursdays. If you haven't done your student introductory, please do it because the university actually requires it for like student benefits or something. I don't want anyone to lose. Yeah.
Yeah, I've done it.
Okay. And then the actual, and the one that's related to the content is here, and they're always due on Thursday. And then the responses to 2 other students are due by Sunday. I recommend you try to do these before coming to class so that you have like a good, like, you know, something to bring to class to discuss, or like maybe, so for next week, we go more into predictive. So we talk about how an organization can apply those to facilitate decision-making and recent examples. And so I'm gonna ask you, like, what examples did you find and why did it interest you? So it would help if you did that before class on Thursday as opposed to waiting until after.
Okay, and the spreadsheet modeling assignments, is it due on Thursday too, or?
Sunday. All assignments are due on Sundays.
Okay.
And next week we can talk about this. We're gonna have to figure out what to do about the final project. This is my first time teaching mixed mode, and they won't allow you to submit that past June 10th. So maybe we start working on it early and I help you guys out starting around week 8 so that those extra few days don't hurt you guys, but just something to keep in mind. Okay. And I'll kind of figure that out too. I've never had that happen to me before. I've always, but it's something to do with live lectures and dates. And so don't worry about it for now, but just that's going to be the one weird thing is the final. But otherwise you have till Sunday. So you can I like for workflow, I recommend reading all the course material and kind of thinking about the discussion post and getting that ready. And then coming to Thursday class, watching me go through the examples and then attempting the homework. And you could always start attempting the homework earlier too, if you want, so that if you know you're gonna get, like, if you think, oh, I don't understand this at all, you can actually ask me during class. But if you don't get to it before class, at least class will help you kind of see me working through, because the assignments are all going to be based on things that we did, like for example, creating a one-way data table and a line chart. So we did that a couple of times in class today. So you got to see it, and then you'll have the recording so you can go back and reference. Okay. Okay, and don't let these daunt you. I mean, these are pretty simple tasks. I know it looks like a lot of verbiage, but this shouldn't take you like all day. If you're really getting stuck, I really want you to stop and call me, and we'll do it together. So that you're not like, we're all adults and we all have like this is not, you know, like traditional college where like you have all day to sit around and like think about. So just call me. And I'll help you. I do not want anyone spending hours and hours on one problem. All right. Thanks, you guys. Sorry for going over. I appreciate it.
Thank you.
Thank you.
Thank you.